there. So we're looking from the Tulsa radar, and this is our normalized rotation tool. And the more I'm looking at this, if you were watching earlier, I said we weren't seeing those reds at the time, but looky here, the red has come back. So there is some strong rotation with this. This might be starting to recycle and may eventually produce again if it's not already. We're going to take a look. Okay, radar confirmed tornado in 10 killer. We don't want to overhype this, but this is our debris tracking tool. And this is going to show us where a tornado would be located. We have a confirmed tornado on radar in the community of 10 killer. You're looking at it with us here, folks, as well, but it's not multiple tornadoes. This is the history of the track of this storm. Notice the debris signature has been with it all the way since northwest of Marietta. So this is still a concerning storm. So I wanted to take a look at okay, this is a tool that is unique to us. This is what we call the TDEF. Now, this is the computer putting together the conditions of the wind, so it's taking into consideration the shear and the winds that are within the signature with the velocity. And when we start to get into those reds, that is concerning. So this is showing us basically the strength equivalent. And again, this is not to overhype, but right now, this is saying this could be potentially high-end EF2, low-end EF3 strength. Again, we're not going to say that this is that because we don't get those rankings immediately until the National Weather Service does a full damage survey. But this is helping forecasters determine the kind of intensity that is going on with the tornado. And to me, because we have had this debris signature for so long at various levels of the atmosphere for this long, this could be potentially high-end EF2, low-end EF3 strength. We're not saying it is. We don't want to say it is confirmed that, but this is the computer algorithm telling us the intensities that this could be. So this is potentially still an ongoing significant tornado. And well, it's the day of the full solar eclipse on April 8th, and it is finally here. I'm going to show you what causes a solar eclipse. Starting off with, here's a look at our sun, our moon, and our earth. Notice how small the moon and the earth are compared to the sun. You might be wondering, how is the moon going to cover all that sunlight? Well, the reason is its distance. The moon is 400 times smaller than the sun, but the sun is 400 times farther from the earth than the moon is. So that's going to lead to more of a distance thing, leading to the light being blocked by the moon. And the other reason we're seeing this eclipse is because the orbit of the moon. We don't see eclipses every year because it's on a 5-degree tilt on its axis, so it's either 5 degrees above or below the horizon. But this year, it's going to be perfectly in between our view on Earth and the sun. So that's going to lead to the full solar eclipse. So here's a quick breakdown. We are going to be in the total solar eclipse in portions of Arkansas in what's known as the umbra. That's the darkest shadow from the moon. And then areas that are seeing partial eclipses are going to be in the penumbra, which is the moon's partial shadow on the earth. So here's what it's going to look like for areas like in Ozark, Arkansas, around 1:51 p.m. And this is full solar eclipse totality. And we're going to see the diamond ring. So make sure that you're down in areas with totality because it's going to be much more beautiful as we have this glow around the moon that's white and you're able to watch it without the glasses. But here in Fayetteville, Arkansas, we're going to be seeing what's called Bailey's beads. It is still dangerous to look at this without glasses, so keep that in mind. If you're going to go and watch the eclipse, make sure that you're keeping these safety tips in mind. So screenshot these, have those glasses and solar filters ready for any extended lenses. Yeah, and like you could see with Connor's shot, that was a pretty big fire. Here's a look at our satellite with the fire products, and you can see this red and this black area is the flames and the smoke from that fire. It's even visible on all 3 of the radar sites that cover our area. This is from Springfield, and as you can see, this is not rain. That is the fire that is seen on our live scan X-ray Doppler as that beam is sweeping across. Here's some photos that we have across the area. Troy Enbid sent us this over a neighborhood in Rogers, and then this was from our tower cam. Stick around for the full forecast coming up in just a little bit. Back to you. So here's a look at the extended forecast, and there is a big pattern change on the horizon. Take a look at all this energy swinging in from the northwest, and then as we get our way into November 1st, there is going to be a large trough, as we call it, that makes its way into our area. Still watching to see if that means rain and storm potential. Next 6 to 10 days for the temperature outlook, it's going to be above average here in northwest Arkansas. Good news, though, the precipitation outlook looks to be rather positive. We're talking potential for rainfall over the next 6 to 10 days, and then 8 to 14 days, rain is still there, so that's some good news for the extended period.